All right, before we start looking at solving inequalities, I want to go over some notation. We have set builder notation. So let's say we had the interval x is greater than 2, and we wanted to graph that on the number line. There's two ways to do that. One way is to use a parenthesis to indicate 2 is not actually part of that set. 2 is not greater than 2. It's equal to 2. The other way, instead of using a parenthesis, is to use an open circle. If instead we're looking at the set x is greater than or equal to 2, then we would use a bracket to indicate 2 is greater than or equal to 2, or we could use a solid circle filled in. If we're looking at the set of numbers x is less than 2, then again we can use a parenthesis. This time we're going less than, so to the left, or an open circle. Less than or equal to 2, we could use a bracket or a solid dot. So it doesn't really matter if it's going greater than or less than. If it's not including the endpoint, we use parentheses or open circles. And if it's greater than or equal to or less than or equal to, we use brackets. Another notation we could use to describe this set is what we call interval notation. Interval notation is used to kind of relates to the image on the number line, and it's using the ends of the set. So, for example, when we're looking at the numbers greater than 2, we would say we go from 2 to infinity. And we use a parenthesis on 2 to indicate 2 is not included, just like on the graph. If we're looking at the numbers greater than or equal to 2, we would use a bracket to indicate that the endpoint 2 is included. If we were looking at the numbers less than 2, then we would say we went from negative infinity up to 2. And again, parenthesis to say 2 is not included. And if we were looking at greater than or equal to 2, we would say negative infinity, or sorry, x is less than or equal to 2, negative infinity up to 2, and because the 2 is included, we would use a bracket. So the interval notation is kind of make you think of the graphs, the top graphs with the brackets and parentheses. You don't have to use interval notation for this assignment, but it's just something to know. So let's look at the steps for solving inequalities. One of the things we can use is the addition property of inequalities. It's just like the addition property for equations. If A is greater than B, then if you add C to A and you add C to B, you still have a greater than situation. Likewise, we said if C is negative, you could say you subtract C from both sides. And just flip-flopping the inequality, if A is less than B, this property still holds, that you add something or subtract something from both sides, the inequality stays less than inequality. Multiplication property of inequality is a little bit more complicated. If A is bigger than B, and you're multiplying by a number C that's greater than 0. Numbers greater than 0 are positive numbers, so you're going to multiply both sides of the equation by a positive. The inequality stays greater than. A times C is still greater than B times C. Likewise, we could say you could divide both sides. So, again, dividing just means multiplying by the reciprocal. So that falls into this multiplication property. If A is less than B, and again, you're multiplying by a number that's positive, greater than 0, then A times C is still less than B times C. So if you multiply by a number that's positive, no change to the inequality relationship. If instead we have A is greater than B, but this time C is less than 0. Numbers less than 0 are negative numbers. So if you multiply both sides of the equation by a negative number, now the inequality has changed. It was A is greater than B, now it's A times C is less than B times C. So the inequality is flip-flop because we multiplied both sides by a negative. Likewise, if you divide both sides by a negative. And again, if A is less than B and our multiplier is less than 0, so our multiplier is negative, then that's going to change the inequality to a greater than situation. So kind of getting away from all the symbols here, basically what this means is if you multiply or divide both sides of the inequality by a negative, the inequality symbol is going to switch. So if it starts greater than, You divide by a negative, it becomes less than. Start less than, divide by a negative, it becomes greater than. So let's look at the steps of solving inequalities. First step, simplify both sides of the inequality. Next, make sure you only have a variable on one side of the inequality. And usually if you have one on the other side, you're going to add or subtract to get rid of that whole term, just like we said before. Isolate the variable that remains. And again, usually what we want to do is get rid of the constant first and then get rid of the coefficient. If this sounds familiar, it's exactly the same steps we use to solve equations. Simplify both sides, make sure there's a variable only on one side, and then get that variable by itself. Exact same steps. So let's say we want to solve 4x minus 6 is greater than 22. Some things we notice. Right off the bat, both sides are simplified already, and there's already one variable. So all we have to do is get that variable by itself. So first thing we want to do is get rid of that constant term 6. So since it's a negative 6, subtracting 6, we're going to add 6 to both sides. Gives us 4x is greater than 28. And then we're going to get rid of that coefficient of 4. So we're going to divide both sides by positive 4. Since we divided by a positive, this symbol is going to stay a greater than. And if you can leave your answer that way, but if you want to make it more set notation, you can say x such that x is greater than 7. And then if we want to draw that graph, again, remember, since it's a greater than, we can use a parenthesis or an open circle, and we want to be numbers greater than 7, so we want to go to the right. So I use parentheses. I'm going to use parentheses and brackets on here instead of circles, but again, you could use an open circle here if you wanted to. All right, so let's look at this problem. We're going to solve 3x minus 7 is greater than or equal to 5x plus 12. And all these properties we've talked about apply just the same to greater than or equal to, less than or equal to. What do we notice? We notice both sides are already simplified, so we don't have to worry about doing that, but we have x's on both sides of the equation. We only want x's on one side. So what I'm going to do is I'm going to get rid of that 5x term. So since it's a positive 5x, I'm going to subtract 5x from both sides of the equation, combine like terms. Negative 2x minus 7 is greater than or equal to 12. And now I'm going to isolate the variable. So again, get rid of the constant, add 7. That'll get rid of that negative 7. And now I want to get rid of that negative 2 coefficient. So I'm going to divide both sides by negative 2. Because I divided by a negative, that's going to change this inequality from a greater than or equal to a less than or equal to. And again, if you want to fancy that up, you can make it set notation x such that x is less than or equal to negative 9.5. And then I'm going to graph it, and because it's an or equal to, I'm going to use a bracket. So numbers less than or equal to negative 9.5 or to the left. All right, let's look at this problem. So what do I notice? It's not simplified at all. There's x's on both sides. So first step is to simplify. So I'm going to distribute the 2/3 through the first parenthesis. So 2/3 times 9x, 2/3 times negative 12. So 2/3 of 9 is 6, 2/3 of 12 is 8. And then I'm going to distribute the 1/2 through the 4x plus 5, a half of 4x, and then a half of 5. And that gives me 6x minus 8 is less than 2x plus 5/2. And if you want to work with fractions, you can keep it this way and just, try to get rid of your x on one side and do it. I don't like fractions, so what I'm going to do is I'm going to look at all the fractions that remain. There's only one. It has a denominator of 2, so I'm going to multiply everybody by 2 over 1. And that should get rid of all the fractions. So basically 2 over 1 is just 2. So 2 times 6 is 12. 2 times 8 is negative 16. 2 times 2 is 4x. 2 times 5/2 gives you 5. So now we have 12x minus 16 is less than 4x plus 5. Because I multiplied both sides by a positive 2 over 1, again, no inequality change. It's only when you multiply or divide by a negative that the inequality changes. And now, notice I have x's on both sides. I want to get rid of one of those x's. I'm going to get rid of the 4x, so I'm going to subtract 4x from both sides. Again, to get rid of a whole term, not just the 4, but the whole 4x, you have to add or subtract its opposite. 8x minus 16 is less than 5. Let me move this to the top here, kind of running out of space here. And I'm just going to isolate the x. So get rid of the 16 by adding 16 to both sides. 8x is less than 21. And then I'm going to get rid of the 8 coefficient by dividing both sides by positive 8. Again, because we're dividing by a positive, that inequality is not going to change. It's going to stay on less than. And if you want to put set notation on this, go ahead, x such that. Again, you don't have to do that. You can leave it the other way. And then graphing it, parenthesis, because it's not included, or open circle, and less than to the left. So there we go. That's how you solve inequalities. It's exactly the same process as solving equations.